Hi there, this is Mr. Sanders, and this is a review of lesson number 10 in Unit 3. And our exit ticket cool down will be covered in a separate video. So let's get going. What we're doing today is we're trying to prove more triangles are similar. And we'll use the side, angle, side, and side triangle similarity theorems. So let's get going. Okay, there's no vocabulary that we need. And here's the first part. Triangle congruence, evaluate mentally. So stare at this for a minute, and there are actually several more shapes to look at. There are these, a circle with a diameter, two diameters, a square, and this parallelogram. What we're supposed to do is ask ourselves, is there enough information to determine if the pairs of triangles are congruent? And if so, what theorems would we use? All right, so let's take a look. First, there's this right uh, angled triangle, NLNM. We also see some other factors here. The two sides are congruent. And so what can we lead to? Well, it's right here. KM is perpendicular to NL. So that's good. And KL, line segment KL, is congruent to line segment ML. So let's go on and take a look a little more closely. All right. Do we have enough information? Yes, we do. So, for instance, as we say down here, under sample responses, side, angle, side, triangle congruence, side, angle, side. Okay, we know that these two sides here, LK and ML, are congruent, and we have this 90-degree angle. What this tells us is that angle K is congruent to angle M. And if we have two angles, then we actually have the third angle. And we will find that the angle NLM and the angle NLK will also be congruent. That would give us a side and an angle, and we can use LN here as being congruent to itself to be able to say side, angle, side congruence. And of course, if we turned around and used the Pythagorean theorem a little further, we could say that NM and NK are congruent, and then we could have side, side, side. Okay, for number 2, with the circle here, yes. And how are we going to know that these are congruent? Well, there are a couple things. One thing is that right here, these are vertical angles because AB and ED are two diameters for this circle. So those lines are we're not talking about the same length, we're just talking about the angles. But we know that these are vertical angles, so this angle here and this angle here, those two are congruent because they're vertical angles. So now we have two angles, and then since this is a circle and from C center to E or C center to D, these two lines are going to be congruent. And so now we have angle, side, angle, and that proves the congruency. And so down here, that's what it says. Angle, side, angle, triangle, congruence. All right, let's move on. Here is a square. Well, it looks like a square, but we don't have any angles designated at all. So it could actually be a parallelogram, and then the angles aren't going to necessarily be congruent, and we don't know just from this drawing enough about IF or HG to come up with any kind of congruence. And finally here, yes, this is two lines are parallel, AB and DC are parallel to each other, and these are transversals. So we could look at it sideways actually if we were to rotate this 90 degrees, something like that, we could see that these are interior and opposite angles. All right, let's put this back. There we go. So once that's true, and we have this line here, we can prove the congruency with angle side angle. All right. So now here is the next section, 10.2. Andre remembers lots of ways to prove triangles are congruent. He asks Claire, can we use angle side angle to prove triangles are similar? Etc. Here's the dialogue, and they go back and forth. All right. And then what we want to do is answer a few questions. What could side stand for to prove triangles are similar? Let's draw a picture. So here's side, angle, side. So what would a side mean? Side could stand for scaled sides. So both sides would have to be multiplied by the same scale factor. And then we draw a diagram that would help you prove the side, angle, side triangle similarity theorem. Here are two examples. And then finally, I've included writing a proof, but we're not really going to go through all of this. It's quite long. As you can see here, here's the proof. There's a lot more involved here than I wanted to devote in this video. Okay, so this is a quick thing here. 10.3, oops, sorry. What we want to do is prove that these two triangles must be similar. Well, we can see that they're multiplied by a constant, k times c, k times b, and k times a. K is going to be one value. So that is going to be perhaps, I guess, the scale factor for DEF to go to ABC, or from ABC to DEF. And here you can see it says dilate triangle ABC using center A and scale factor K. Since all three pairs of corresponding sides are scaled by the scale factor K, then A prime B prime is equal to DE, right? Okay, A prime B prime, that's C, is equal to DE, and there's the C and the K. And the same is true for the rest of the sides throughout. Therefore, any pair of triangles with three pairs of corresponding proportional sides must be similar. It's essentially saying that if we're multiplying by a scale factor, then the triangles are similar. Okay, are you ready for more? I have included an explanation and a diagram here. Prove or disprove the side-side angle triangle similarity theorem. The side-side angle doesn't work. And here's an example. Triangles ABD, and ABC, here, ABC, share both angle A and side AB, right? Side CB and DB are equal as they are radii of the same circle. So you can see that, and we can mark that this is congruent to this. All right, so triangles ABC and ABD have two adjacent sides that are equal and an angle which is congruent, but these triangles are not similar. This is essentially part of what we had talked about a while ago called the ambiguous case, is that you could have two different triangles with the same set of two sides. In this example, the base AB and then BC fits here along AD, and it also fits over here as BD and still touches AD. So that's the ambiguity, is that it could be either this one here or that one there. Okay, here's your summary of the lesson and what we learned. And the cool down I'll cover in another video. Thanks for watching.